All right, so hello and welcome. I'm Sadhasan, and I have come here to take up this rather insipid problem. So there is, let me admit, even before I begin this problem, that there is nothing remarkable about this problem. But it just so happened that someone I know stumbled upon this problem, and solution to which was present on YouTube, but that was incorrect, and so he asked me that whether I could do it. So without naming names, and I'm not into this business of mudslinging, so I'll just solve this problem for once and be done with it. So there's a problem taken from ISI's 2022 paper, objective, and it says that amongst all polynomials px, c0 plus c1x plus all the way to c10x to the 10, with real coefficients satisfying mod of p of x is less than or equal to mod of x for all x belonging to -1 to 1. What's the maximum possible value of 2c0 plus c1 to the 10? So what we know is that, well, px is c0 plus c1x plus c10x to the 10. And what we also know is that the coefficients are real, and mod of p of x is always less than or equal to x, and for all x belonging to -1 to 1. And then we are supposed to find a maximum value of 2c0 plus c1 to the 10. All right, so before we headlong into the problem, there are a few observations to make. What I see is that c0 is nothing but the constant term, which is in fact p of 0. It shouldn't be that difficult to understand, right? So there could be various ways to attack this problem, right? So what we have first identified is that c0 is in fact p of 0. The first question which I'll ask myself is that, is there a way of finding out p of 0? Because one of the ways to solve this problem could be that we'll be able to find the value of c0, we'll be able to find the value of c1, and then we'll be able to find this value. But in that case, the idea that this will have a maximum value doesn't make sense. So I'm hoping that well, either we are going to find the values of this value of this whole number, or we'll be able to find a suitable bound on this number, right? So well, one of the ideas could be that we can individually look for the values of c0 and c1, or we should be able to find the values of c0 and c1, and then we should go and proceed, or a combination of these two. So it means that you can find one value and get a bound for another value. That could be the case too. Or the other way is that, well, by some sleight of hand, we could put x as some favorable number, and the output that this function will return is going to be 2c0 plus c1, right? And that could also be done, that put x as something so that the output that you get is 2c0 plus something. But might I say that that seems very unlikely, that if you plug in x as some value, it's going to return something like 2c0 plus c1. So what I'm going to focus is on c0. So we have already identified what c0 is, which is p of 0. Since this inequality is valid for all x lying between -1 and 1, and 0 lies between -1 and 1, so I'm going to put x as 0. So putting x as 0 is, what you get is mod of p of 0, and that's less than or equal to 0, which means that, do you see that where we are arriving at? So there is a modulus of a number which is less than or equal to 0. Obviously, it's almost trivial that the modulus of a number can't be negative. So which means that mod of p of 0 must be 0. So p of 0 is such a number whose modulus is 0. We know that there is only one number whose modulus is 0, and that's 0 itself. There is no other number whose modulus is 0, which means that p of 0 is 0. Well, that's kind of nice, don't you agree? Because that tells you that c0 is 0. So, well, the thing that we have to maximize is, well, c1 to the 10. So if we could find c1, or if we could find a bound for c1, nice bound for c1, we'd be able to identify c1, right? So what px becomes is, so now px is rather c1x plus c2x squared plus all the way up to c10x to the 10, something like that. So now I'm trying to identify what c1 is. So I believe it's not that difficult to see that C1 is simply P dash 0. Well, it's not difficult to see rather, because you can see that P dash X is C1 plus 2C2X plus so on. 10C10, X to the 9. Oh, I have differentiated this, but I don't think that this was required. But never mind, you can see that P dash 0 is C1. So I need to find a bound on P dash 0. Okay, right. And the only inequality which we have is that well, P of X is mod of P of X is less than or equal to X. And that's valid for all X belonging to -1 to 1. So I'm going to divide this inequality by mod of X. So what you get is that mod of P of X upon X is less than or equal to 1 for all X belonging to -1 to 1, and X shouldn't be 0 because we have divided by X, so X can't be 0, and that's kind of obvious, right? I'm going to make some changes in this inequality. Do you agree that this inequality can be written as a Px minus P0 upon X is less than or equal to 1 for all X belonging to -1 to 1 except 0? Yeah, that should be obvious, isn't it, right? So this inequality is valid for all X which are lying in this interval between -1 and 1, but X shouldn't be 0. Well, X shouldn't be 0 is fine, but we can always make X arbitrarily close to 0. And well, arbitrarily close to 0 means in mathematical terms, limit X tends to 0. So we can say that limit X tends to 0. A P of X minus P of 0 upon X is less than or equal to 1. You agree that limit X tends to 0 doesn't contain the number 0 itself. So this is going to be valid. Well, if you look at it, there's nothing but the definition of P dash 0. So you get that mod of P dash 0 is less than or equal to 1. So which means that mod of C1 is less than or equal to 1, which means that C1 to the 10 is less than or equal to 1. And we are done. So the maximum value of C1 to the 10 is 1, and we are done. We were supposed to find the maximum value of C1 to the 10, and we're done. So the answer should be 1. All right, and we're done. I just wondered that why did it choose this polynomial of 10 degree and why not a polynomial of, say, 2022 degrees, since this was the year in which this examination was conducted, and this would absolutely make no difference to the proposition itself. The answer would still be 1. But well, I'm hoping that they didn't just want to intimidate the student by taking such a higher degree polynomial. Okay, that's all about this rather short video. In fact, what I'm going to do is that in the next video, I'm going to take up a problem from British Mathematical Olympiad. That's kind of nice, because British Mathematical Olympiad doesn't expect you to know a lot of things, but it expects you to do a lot of things, and there is a difference, right? So I'll be quite interested in taking that problem up in the next video. All right, that's all about this problem. Bye.